Bro 07 here, and today we're going to be talking about improving your program's reliability with new reliability techniques that you can use. So let's jump right in and talk about today's lesson objectives. So today we're going to learn how to make your robot more reliable. We're going to learn about common problems you might face if you're an FLL member, and some possible solutions for those problems. So do not fear, because Builder Bro 07 is here. And today's lesson is once again focused on reliability issues faced by FLL teams. And these concepts in this lesson can be applied to non-competition situations, but this is mainly focused for competition robots. But if you are not in any competitions, this will also help you a lot. So first we're going to talk about the sources of problems you may have. So one problem is starting alignment varies from run to run, and the impact is each run is different and missions sometimes work. So what this means is that every time you realign your robot for a new run, a new mission, whatever you want, it might be a little bit different from the place you put it, because no human is perfect, and you're always going to maybe miss the exact alignment by a little bit, like maybe a centimeter, millimeter or so, which can also hugely impact your missions, because most of the time if you make it a little bit off, then the mission will not work based on the program that you have, which is not good. And we will be fixing all of these problems very shortly. So robots don't travel straight for long or turn exactly the same amount. So that's talking about the move steering or move take block, and it is very hard to predict the robot location exactly, which makes your programs or missions very hard to program, because you don't know where they're gonna end up every single time, which can make it hard for the future. And another problem is errors accumulate as you travel. So what this means, and I have prior experience with this problem as well, is that if you're doing a longer program which has multiple missions inside of it, then it'll be harder to be accurate, because let's say your first mission has 100% accuracy because it's closer to the launcher or base. Then the second mission may have 80% accuracy or 75% accuracy, and then your third mission might have like 50, and then so on, which means that long missions tend to fail, and it is hard to do missions far from launch/home. Battery levels impact motor performance, which we have learned about before. Tweaks that work today may fail tomorrow, because one day you might have 100 battery and you're programming things to go exactly the way you want at 100 battery, but then the next day it might be a 75 battery and it won't work, which is very true, and I have prior experience as well, which is not good. Starting points in launch are critical, and in First LEGO League, teams need to figure out where to start in base. So as you see here's a base, and there are many things you can do in order to make your robot start in the same place every time. You can use Jigs, which is a LEGO ruler/wall that a robot can align with, as you guys can see right here. You can same start every time. Pick one spot and start there no matter where the mission starts. You can use the grid/radial line, as you can see here. My team usually uses grids, and we also use this white box right here, as you guys can see. And you can also use the words, because Lunch has grid lines in a First LEGO League Lego, and if you aren't near an inch mark, pick a word or letter to start on. So last season we used the grids, and we also use the words for sometimes reference, but usually use the robot for the top of the box or under the box, or use these small little grids, as you guys can see here. And we didn't really use a jig, but jigs are really helpful as well. And even better, try to find a way to align the robot using other techniques, as you guys can see here. So errors accumulate over time. By the time you get to the far side of the table, you're no longer in the right position, because it is very hard to move straight for a long period of time. And in the real life, if you have like a moving car, if you don't steer it at all, then it will not go straight, and prior to popular belief. So here's the solution. Repeat alignment techniques multiple times in order for a run to have better reliability, as you guys can see here. So where are you on the FLL table? This can help your alignment strategies. So as you see here, you can align with walls, which we used in the FLL City Shaper season. as you guys can see here, you have a line with the wall, and then you can go out and do whatever mission you have to do. And you can square a line on line using the color sensor. As you can see here, there's a black line, and your color sensor can snap on the line, and then if you have another color sensor, it can line square. And then you can move until a line. So basically, you can line follow and travel until you find a line, so you know where you are on the map. And you can also finally align on a mission model. So mission models that are stuck in place can be used to align with. So it's sort of like a wall, but the wall is the mission model now. So some other factors in reliability. So battery life takes a huge part in reliability. If you program your robot when the battery is low, it will run the same when it's fully charged, which we just talked about. So be sure you always program on relatively the same battery level, which is very important. And motors behave differently with low battery, and sensors do that as well. Lego pieces come apart over time, so be sure you make sure your attachments and robot is well put together, and squeeze in Lego pieces in key areas before run, which we had to do in our Stage Shaper season as well in the regional and state competitions. The pegs get loose, which means the sensors may not be in the same place as the previous run, which is not good, and push in wires for sensors and motors. They come out, and I'm sure that most of you guys have had that experience before as well. So motors and sensors don't always match. Some teams test the motor, sensors, and wheels to make sure they match, and we have done that as well. And you will never get a perfect match, so we recommend use other techniques above and accept that they will be different. As always, it's been BuilderBro07. I hope you enjoyed today's videos. As always, be sure to like and subscribe, build on, and see you in the next video. Bye!